In this problem, it says that a survey found that women's heights are normally distributed with a mean of 63.4 inches. So I'm going to mark that on my normal distribution here. And the standard deviation is 2.4 inches. So I'm going to make a note of that up here. The mean is 63.4 and the standard deviation is 2.4. A branch of the military requires women's heights to be between 58 inches and 80 inches. So I'm going to mark that on my distribution as well. So 58 inches is going to fall approximately here, and 80 inches is going to be way off the distribution. So I'm going to put it out here. It's really further out, but that's what I can fit on the screen there. So what we want to do is find the percentage of women meeting that height requirement. And we can see that that's going to be most women. This is going to go out towards that 80. And we have a very small percentage in this tail that would not qualify. So how do I calculate that probability? The probability that my value is between 58 and 80. I'm going to use the normal CDF function. My lower limit is 58 and my upper limit is 80. The mean is 63.4 and the standard deviation is 2.4. So I get to this normal CDF by pressing second and variables. And normal CDF is the second choice in that list. So when I calculate this, I get 0.9878. So we want to write that as a percent. That's going to be 98.78%, rounded to 2 decimal places. So that's for the first part of Part A. Then they have a question about, are many women being denied the opportunity to join this branch of the military because they are too short or too tall? So since almost 99% are going to be accepted under this rule, then we would say, no, there's only a small percentage of people who are not being able to join the military because of being outside of that height range. So let's take a look at the second part of this question. So here we can see that I chose, no, there is not a large percentage of women who are do not have the opportunity to join this branch of the military. So now in Part B it says, for the new height requirements, the branch of the military requires women's heights to be at least what? Let's see. So our new height requirements, we are going to allow everyone but the shortest 1% and the tallest 2%. So let's look at our distribution again. Since they said we want to accept everyone but the shortest 1%, we're going to cut off the bottom 1% and then the top 2%. I'm going to say that's roughly there. And I'm not terribly worried if I guessed that cutoff accurately. So I just want to get an idea that there's about 1% there, about 2% here. So how do I determine what the value is here? Now we have the area and we want to find the height that corresponds to being taller than the bottom 1%. So what we'll do is we do the reverse of what we just did. Instead of using the normal CDF function, this is going to be the inverse norm. And I have 1% on the left, and the mean of the heights is 63.4, and the standard deviation is 2.4. So when I calculate that, I get 57.8 inches rounded to 1 decimal place. And so that's what's going to go in here for at least 57.8 inches. And then at most how many inches? And let me put that up here. I'm going to say inverse norm. Shift this over. We're going to need more space for that. So now we want to find the score that falls just below the top 2%, or the height that falls just below the top 2%. So if we're looking at that, what we mean is we want the score above the bottom 98%, because 98 plus 2 gives me 100%. So we have 98% on the left. The mean is 63.4. The standard deviation is 2.4. And we get, let's see, what is the height? 68.3 inches. So that's what's going to go there. And that's how we solve that problem.